Welcome. My name is Ólafur Arnalds and I am a professor of soil science and a studies committee member and teacher of the UNU Land Restoration Training Program. We in the group behind this module look forward to sharing with you our experiences on the importance of preventing land degradation and restoration of degraded ecosystems. In this video, you will learn about ecosystems and the services they provide us, and you will gain understanding of the importance of ecosystems for achieving the UN Sustainable Development Goals. Ecosystems provide us, human beings, with services through three vital ecosystem cycles: the energy cycle, the water cycle, and the nutrient cycle. These cycles make our planet unique and rich. But before discussing those cycles, let's take a look at our home, the Earth. We live on a remarkable planet with such richness that it may not be rivaled in the whole galaxy. This richness provides us, human species, with food, clothing, building materials, medicines, and it is the basis of our life and economy. Agriculture, the provision of our food and clothes, is by far the largest business sector on Earth. The value of agricultural commodities per person each year is about $500 to $1,000, and we, human beings, are nearly 7.5 billion. This adds up to $7,500 billion every year. This is a lot of money. And we have come to take this richness for granted. We need healthy ecosystems to produce our food and other goods, but land and ecosystems provide us with much more. Many of these functions and services that ecosystems provide us are not directly visible or easy expressed in monetary terms, but crucial to support our economy and human well-being. There are, however, many examples where unsustainable use of natural resources has had dramatic consequences. But first, let's ask ourselves, what is it that makes our planet so unique and rich? The answer lies in those three ecosystem cycles that drive life on Earth: the energy cycle, the water cycle, and the nutrient cycle. I will now explain these cycles to you, and I will start with the energy cycle. The Earth's atmosphere is only a few tens of kilometers thick. That may sound like a lot, but it is actually so thin relative to Earth's size that is, from space, it looks as being razor thin. This thin layer contains the oxygen, moisture, and carbon dioxide needed for the maintenance of life on our planet. It distributes the moisture and heat around the globe and protects us from dangerous cosmic radiation. But we need more than that. It took 3 billion years for a unique and complicated system to evolve, where carbon and oxygen provide energy to drive the life cycles on Earth. We call it photosynthesis. In photosynthesis, the green cells of plants harness the energy of the sun and store it as energy-loaded carbon compounds, generating oxygen as byproduct at the same time. The carbon compounds are the energy source most living organisms depend on, including you and me. Organisms feed on those compounds and use them for maintenance and growth and breathe them out as carbon dioxide, thus releasing the carbon again where it will be recharged by the sun and green plants. This is the energy cycle. Let's turn to the water cycle. All the chemical reactions required to make life possible depend on water, plenty of water. And for many purposes, it needs to be fresh water, not salty. Fortunately, there is a lot of fresh water on the surface of Earth, but it is very unevenly distributed. Some land has abundant fresh water and some has very little. This is, of course, no news to you. Fresh water is provided to ecosystems by rain and snow. However, there needs to be some medium to retain the rainfall within the ecosystem and to store it so it is accessible to plants when they need it. There is a part of the surface of Earth that does exactly that and much more. It is absolutely vital for life on land. Do you know what it is? It is called soil. The soil, the dirt, the earth, the true mother of life. Soil has the ability to capture water from rain and store it so the roots can absorb it when the plants need it, even weeks or months after the last rainfall. It is a vital component of the water cycle that sustains life. We will come back to the soil later. Thus far, we have made a brief mention of two vital cycles, the energy cycle and the water cycle, and now we need to introduce the third, the nutrient cycle. We did mention that carbon compounds are the energy source for most living things, and carbon is assimilated from the atmosphere through photosynthesis. But all plants, as other living beings, need a lot more than carbon. We need nitrogen, potassium, and phosphorus, and also calcium, magnesium, sulfur, all this stuff that is called nutrient supplements and vitamins in the stores. Some of these materials are needed in large quantities, others in very small amounts, but are still vital. And this is what the soil does. It provides plants with necessary nutrients. How does the soil do it? The soil can do so because it is not a static structure under the surface. On the contrary, it's very active. It's an active reactor, ever-changing, the largest biochemical factory on Earth. Soil is formed out of bedrock through chemical and physical processes commonly referred to as weathering. This weathering process results in the release of nutrients and in the formation of clay minerals. The clay minerals are exceedingly small units with very special characteristics. A spoonful of clay can have a surface area about the size of a football field. That is a lot. This huge surface area by such small volume of soil and the chemical nature of clay minerals explain why soil can retain so much nutrients and water and make them accessible to plants. The soil also stores organic matter from decaying plant residues, which provides the energy for the soil organisms and abundant supplies of nutrients. But it takes a very long time for a fertile soil to form from the original bedrock and organic matter. Thus, it is so important to avoid soil loss and degradation by erosion. We have provided you with the image that the soil is a colossal chemical reactor, a factory. Well, all factories need workers on the floor, and the labor in the soil is provided by the soil organisms. The soil is full of life, and the organisms range from being microscopic to quite large in size. This life is the workforce of the nutrient cycles. The organisms of the soil consume the dead carbon material, the organic matter, digest it, and release nutrients in the form that plant can use for growth and reproduction. This life is extremely diverse. In fact, there is much more biodiversity found in the soil compared to life above ground. This life is necessary for the nutrient cycles on land, but is also an extremely important component of the diversity of species on Earth, some of which have provided us with many important functions such as medicine and pest control. As an example, antibiotics came originally from soil organisms. The soils of the world have very diverse properties. Over time, a soil develops a character much like human being, shaped by the environment it evolves in. Be it the light-colored shallow soils of the arid regions, the dark and fertile soil of the grasslands, the red and old soils of the tropics, the colorful soils of the coniferous forests, or the cracking clay soils of the river deltas. The soil thickness, its color, the size, the nature of the soil particles can tell you a story of thousands of years of evolution, reflecting human impacts and changing climates. We have now introduced you to the three main cycles responsible for driving ecosystems and agricultural production, with water, vegetation harnessing of energy, soils, and the soil organisms being the key components. Ecosystems provide much more services than food production. These include regulating water flow, reducing pollution, providing food, wood, and materials for housing, clean air, and clean water. They also provide resources of recreation and often have important aesthetic value. Many of these are services that are difficult to appraise by economic or monetary measures. Their value is really beyond all comprehension since they sustain all crucial parts of the natural and human environment. We hope it is thus absolutely clear to you now that healthy ecosystem in which the three ecosystem cycles function properly are the pillars for sustainable development. We want to illustrate the importance of healthy ecosystems also in relation to climate change mitigation. Much of the carbon dioxide in the atmosphere responsible for the climate change originates from the soil and was released by relentless use and misuse of terrestrial ecosystems. The good news is that significant part of the greenhouse gases in the atmosphere can actually be returned to the ecosystems again by restoring ecosystems. This is one of the solutions we have to mitigate climate change and is recognized by the UN Framework Convention on Climate Change. And there is more. Land restoration is the answer to problems addressed in two other UN environmental conventions, the UN Convention to Combat Desertification and the Convention on Biodiversity. Restoration and sustainable land management should be our goal. You can read more about the link between soil carbon and climate change in a UNCCD science policy brief paper and in a newspaper article that you can find in the next section of this MOOC. In the next video, you will be introduced to the concept of land degradation and its consequences for ecosystem processes and services. You will also learn about the main processes, signs, and drivers of land degradation. So stay tuned.